All right, let's see. Your exam schedule has been released. Please check the registrar website, but it's going to be this. I don't think it's going to change. And also, written test number 2 is going to be next Friday. So tomorrow, Friday, just normal optional Q&A session there. TA will be there. If you got question about the lab 4, feel free to drop by and ask. Also, we got the online on-demand TA help hours. So if you need any help, reach out. But for lab number 4, it's going to be very critical for the last programming test that's going to happen on the last week. So just get yourself, struggle through, and then I'll release a solution after the deadline. And the written test number 2, I'll release the guide pretty soon, and then also some practice question there, and also review session next Wednesday. I'll reach out to you guys about the detail. It's going to be very consistent, like before. Any questions about the course? Okay. Let's now do some recap about from last time, quickly. So last time, we actually talked about static type and also a little bit of dynamic type about dynamic binding as well. Sorry. So here we got inheritance hierarchy, we got students, and also we got resident students, right? So when you declare the reference variables here, you will see student versus resident student. As soon as you see the static type, you will know that the expectation will be different, right? So now over here, if you see that S is assigned RS, so this is something that's going to compile. Let's repeat the reason again, right? This is something we're going to repeat over and over, and today we are also going to make it general. The inheritance hierarchy you're going to consider may not be just like 2 layers, like a layer 1 and layer 2. It might be multi-layers, like the smartphone example we saw last time, right? That's something we're going to dive into as well. What's really important is, number 1, if you look at the subclasses, like a resident students, because in the subclass, you can introduce new attributes and new methods. So we know that the expectation for the resident students being the subclass would be larger than the expectation of its parent class, which is students. Since the expectation is actually different, especially the subclass always will be larger in terms of the expectation. When you do the variable assignment here, you got to be very, very careful. All right? Let's think it this way. What you want to think about is when I do this variable assignment here, this variable assignment is definitely going to compile, but think about what's going to happen after executing this at the runtime. Because if it compiles, of course, you can execute it at the runtime. So I want to draw just one more line right after this. Okay? So let's say right after this line, since I have done this assignment already, so I can now say S dot something over here. All right? What can I put after the dot such that things will still work? In this case, you got to think about expectation. Specifically, if I want to say S dot, in order to see what this might be valid, I need to look at the static type for students. I need to look at the static type for S, which is students. And then I want to think about, can this RS, which is the objects that S is now going to point to, right? That's exactly what the visualization for variable assignment. Can RS itself, being a resident student, fulfill all the expectation on S? The answer is yes. Because resident student got everything that student has. Even though he got something additional, that's okay. As long as everything that's kind of expected on S being a student, it can be fulfilled, we are fine. But if you argue the other way, it's not going to work. So what I would encourage you to do is to go back to the recording from last Thursday or Tuesday. When I talk about the intuition of polymorphism, when I talk about proof by contradiction, that's where you have to go into and dive deep, right? So you really want to understand about if I say S equals RS versus RS equals S, they are different. And the way to understand why one should really compile and the other one shouldn't compile is by looking at the expectation. All right? So that's something I want to recap very quickly. If you still find confused, maybe just go back to the previous part and look at the slides and try to figure something. If still struggle, let me know. I can help further. Okay? Any question on this page specifically? We good? Okay. All right, and we talk about visualizing parent versus child objects, and the highlights will be whenever you're doing a parent object, of course, you put all the attributes that's relevant for your visualization, and then for child objects, it's going to inherit all the attributes from the parents, and for individual type of the subclass. For resident student, I have some new attribute called premium rates. And for non-resident student, I got some new attribute called discount rate. So when you do the visualization, you also got to watch out what should be included. And then, so this is some, tracing. Okay, as I promised, I want to show you guys something very quickly about dynamic binding. So what we said last time was, when you try to execute Jim.getTuition versus Jeremy.getTuition, because Jim has the dynamic type resident students, the get tuition is going to be from resident students using premium rates. On the other hand, Jeremy has the dynamic type resident students. So the get tuition that's going to be called will be from discount rate, which is non-resident student. How do we see this in Eclipse? All right, let's take a look. The code is already on the website, the lecture site. You can download it and import it to Eclipse. So let me show you very quickly how you can verify this. So the project, once you import, is going to be, it's called example inheritance. Okay? There are two packages inside. One is with the inheritance, the other one is without the inheritance, which is the design number 2 that we spoke about. Okay? So if you go under with inheritance, you can see that we got in students, we got this get tuition, which calculate the base amount right here. If you look at one of the subclasses, for example, let's say resident students, which is over here, right? You can see resident student extends students, number 1. Number 2, if you look at the get tuition here, we're using the super keyword over here to call the parent version. I'm going to show to you how you can trace this as well. All right, let's now take a look. Before I launch the debugger, one more thing. So now if you look at the tester over here, you can see we got Jim and Jeremy. Right? You can see for, okay, let me just click on this. If you look at Jim, Jim has the dynamic type resident students right here after the new keyword. Jeremy has the dynamic type non-resident students, right? So they are different dynamic types. What we want to do is we want to see when we execute Jim.getTuition versus Jeremy.getTuition, which version is going to be called. All right, let's now take a look. So I put a breakpoint in line number 39, so right before we try to call Jim.getTuition, right? So put a breakpoint there, and then let's launch the debugger and see. Okay, I'm going to show you very carefully about what you should really know. Okay. All right, let's now switch to the debug perspective right there. All right, so you can see that. Okay. So now we are pausing right here, line number 39, right? Right before we say Jim.getTuition. Now I'm going to step into. The step into is going to execute Jim.getTuition. And then we're going to step into a version of the getTuition. But we got 3 versions here. We got students, we got resident student, we got non-resident student. So which version am I going to step into? Right? It depends on the dynamic type of Jim, which is resident students right here. All right, let's now verify that. Now I'm just going to step into right here. If I step into, you can see that I'm now under resident students, and then I'm now in the getTuition method for that, right? That's the version being called. And then as the first line, remember we said super.getTuition. What I said earlier in the lecture was super means I want to go to my parent class and call that method. What if I step into again? I'm going to get to another version of the getTuition, which will calculate the base amount only. So let's try that one more time. If I say step into, now I'm now in the context of students. And then I'm now in the getTuition method here. Right? Okay, so far we have seen 2 versions of the getTuition being called. You want to know exactly the sequence and which one's being called. Okay, one more thing. So let me just step return. Okay, so now we are done with 39. Let me now step over. Now I'm right before executing line number 40, right? So this is another method call here. It's Jeremy.getTuition, right? You can see Jeremy.getTuition. Which version is it going to be called? Jeremy, you got to look at its dynamic type. Jeremy is right here, non-resident students. Now if I step into, which version am I going to see? Right? That's something you want to answer to yourself right away. But let's verify that. If I step into again, you can now see we are now under non-resident student class and then get tuition method. And you can double check that one is using discount rate. And as the first line, if you step into it, super.getTuition, which one do we go to? Student version, right? So now you can see exactly how the three versions are being called at the runtime, depending on what the dynamic type is, and exactly how the overridden version is being defined using super keyword. So these are the details you have to know. All right. Of course, feel free to modify the code, create your own example to really test about how dynamic binding is going to work. And we're going to talk about dynamic binding as well on the smartphone example, which will involve multi-layers. All right, that's something you can also try on the Eclipse. Okay. I hope that's clear, and then you can try to reproduce this little experiment here just to to reinforce your understanding. Right, any question about this Eclipse demo here? All right, clear? Okay, let's now move back. All right, we'll talk about dynamic binding and just about calling different versions of the method, right? That one there you can look at that. And just notice that this example here in some way is a little bit trickier because you can see the static type here for S is different from the RS, which has static type resident students. In order to see why it is valid, that's the assignment, like a variable assignment I spoke about substitution, right? That's something you also have to know how it works. Very often, or more often than not, you will actually have to somehow judge, first of all, about variable assignments, whether or not it should compile at a compilation time based on static type. Number two, at the runtime, which version is going to be called based on dynamic binding. Okay, so these are the two things you want to make sure you also get. Right, and I think that this is just some additional exercise we did kind of based on your fellow students' question. So you can follow that, right, just about modifying some class. I believe what we tried to modify was we tried to get rid of the get tuition from the student class and how things are going to change accordingly. I think it's a very great question. I also dived that into detail last time. So look at it. You can study the discussion. I think it's going to benefit. All right, so that's the principle for you. Whenever you want to talk about compilation, decision, static type, and runtime, especially about version of the method, and also exception, especially class cast exception, which we wouldn't really get to today, but most likely on Tuesday. Okay, Tuesday or Thursday next week. Okay, but you want to remember these principles. All right, we'll talk about modifiers, about either for class or for attribute methods. It's a pretty straightforward topic, but it's important. So apply what we learned from Tuesday about modifier to your lab number 4, right? You can decide which attribute should be private as opposed to protected, which is some principle I also spoke about right here, right? You can go over that too. All right, that's kind of towards the end of Tuesday. We talk about multi-layer. So this is one example here. We're just going to expand the student management system hierarchy, right? So for each hierarchy here, you really want to go over design number 1 and 2, the non-inheritance solution. How would you do that without the inheritance? And also you want to think about the design principle, cohesion, single choice principle. How are they going to be satisfied versus being violated? Think about these two. And also for design number 3, you're going to use the extends keyword, which is so important for you to visualize how the inheritance hierarchy is formed, which we'll also get to today. And that's the example we're going to use as a running example for the rest of the inheritance lecture about smartphone, right? So for that one, I'm not going to repeat. You guys can take a look. Whenever you got any doubts about the details, you can always refer to the diagram, which I also make available on the lecture site. Any question from last time? All right. Question. Go ahead.
So, Professor, you asked the question of whereby which get tuition method is being employed at runtime. But when we went to the actual get tuition method for both context objects, there was the super.get tuition. If you want to ask us on that particular line of super.get tuition, which get tuition method is being called at runtime or compilation time, which one what's the answer?
So, okay, so let me just go back to the code over here. Let's say if the question was like, which version of get tuition is being called right here in gym.get tuition, resident students, okay? And then, depending on the context I'm asking. So in this context here, gym.get tuition should really invoke the resident student version. And Jeremy.get tuition should invoke the non-resident student version. Okay with this?
Yes.
Good, okay. And let's go to the second part of your question, right? So let's say if I move into resident students, okay, let's say here. The question may go like this. Let's say we are now executing the get tuition method from the resident student class. I'm asking for this line specifically, right here, using the super keyword, which version of the get tuition will be invoked? In this case, the student version. Okay.
So in this case, will you ever ask about runtime or compilation as to?
Of course, if I ask about which version will be invoked, method invocation is always at the runtime, right? Compilation is only about whether you got compilation error. Runtime is more about which version will be called, and also if you call the method, are you going to run into any exception, right? It's a different concern, right? Okay. All right, let's now do a little bit of exercise, just get ourselves a little more familiar with the expectation and also the smartphone hierarchy, okay? Just this one here, and then we'll move on to something visual, okay? Well, this one is already visual, okay? Let's say we're given this hierarchy over here, and then we want to just practice our understanding about expectation, okay? And of course, expectation will only be based on static type, right? Any class can be used as a static type as long as this class is declared somewhere. Of course, we're assuming that every class in the hierarchy here is declared somewhere. Maybe you can create a project on your own. Let's now focus on 3 classes in the hierarchy, right? I'm going to color them right here. The first one, iPhone 13 Pro, the blue one. Okay. And the second one will be, let's say, Huawei P50 Pro, right here. Okay. That's the second class, the orange one. And the third one, the Samsung Galaxy S21 Plus, right here. Right, we got 3 classes. They somehow just got located in different parts of the hierarchy, right? Let's talk about expectation. And then we can see some pattern around them as well. So that may also help you generalize how the patterns can be somehow shared or derived from different classes in the hierarchy, all right? All right, let's now just take a look at this one here. What about iPhone 13 Pro? What exactly will be the methods you can call on iPhone 13 Pro? In this kind of situation, you can start from, it's kind of up to you. You can either start from the top of the hierarchy and go all the way to over here and see what methods are being accumulated along the way. That's one way, top down. Or you simply want to start with this class over here and go bottom up. That's also fine. Why don't we go for bottom up, all right? You can see for iPhone 13 Pro, we have a new method called Quick Take. Okay, I'll put it right away. And then I will go up. I go to iOS. iOS has these 2 methods right away, even though they are being overridden, but since I know they exist, I'll put them right away. And then I also got Surf Web. And also I got FaceTime. Well, these 2 are a little bit different. Okay, let me just say that. Okay, let me just do it again. You can think about the FaceTime over here is the new method we introduced in iOS, right? So I'll put FaceTime first. And then the Surf Web over here is something inherited from smartphone. I just override it, right? And then I will put Surf, And then I'll put Surf Web. Okay. I'll put Surf web, and then if I go up again, I will have dial, right? Dial is also one of the basic features. So that's the expectation, right? So far so good? Okay. So let's say for the second one, we can do a little bit quicker. What would be the expectation for Huawei P50 Pro? So basically, start from here, I'll go all the way up to smartphone. So now I can see what methods are being accumulated on the way. So zoomage will be the first one, right? Zoomage, and then nothing new in Huawei. And what about Android? The new one is Skype. And then I also got surf web and also dial, right? Similar. You may already observe certain pattern to see that certain expectation they will overlap for some reason. Okay, we'll get there in a moment. Okay, let's do another one, the final one. Let's say Galaxy S21 Plus, right? So that one there, if again I go bottom up this way, right? Right, also this way, bottom up, right? So that one there also is an Android phone. So Galaxy S21 Plus, nothing new here. But in the Samsung level, we got side sync. So I got side sync. And then I move on to Android. And Android here will be just the same. Okay, I beg your pardon. Yeah, let me just erase this. I should have aligned that a little bit better. Okay, so I'll put side sync to here. And then since now I'm looking at Android, which has been looked at before, so we got surf web and Skype. Right, Skype and surf web. And then I go all the way back to the top, which will be dial. All right? So that's about the expectation, which we try to figure out individually. But let's observe some pattern. For example, you can see that right here. All these two. Surf web dial, surf web dial, surf web dial. It's because all these three classes are all under the smartphone. What we call them the descendants, which I'll declare a little bit more define a little bit more formally in a moment. But I can see iPhone 13 Pro, if I go top down, I can eventually get to smartphone. Huawei, if I go top down, I can also eventually go to smartphone. From here, if I go top down, I can also eventually get to smartphone. So it's more like a common ancestor. That's what we call. So in this case, these expectations from smartphone are inherited to 1, 2, and 3. Okay? So that's something you can note. So these are the expectations from the smartphone. And then one more thing, similarly, if I try to look at the Skype right here, right? You can see only these two phones actually got Skype, but iPhone doesn't have it. How come? Because if you look at this here and this here, if I keep going bottom up, they will reach this common class, common ancestor. That one there has the Skype. But the iPhone 13 Pro, if you go bottom up, you're not going to reach the Android. So they are not under the same common ancestor, right? So that's why. All right, so for that one there, I'm going to put it right here. So this will be the expectation from Android. Right? So this kind of expectation and see how the expectation are being inherited are very important insights when we talk about substitution. So it is important. Right? Questions about this? And this is just one example here, but if I give you a different hierarchy, you should also be able to figure out how the expectations will be inherited and how they overlap. Okay, good. After this, okay, so let's now talk about ancestor and also descendants, or also expectation. I can just make it a little bit more generalized. So this will correspond to slide number 40. Okay? So slide number 40, we kind of went over that very quickly last time. But I think the first part here, just about the extends keyword, right? So let me just visualize that one more time. So the way to understand it is, so let's say we got 3 classes, right? So we got class over here. And then we got class over here. So let's say we got X, and also we got Y, and also we got Z. Right? We got 3 classes. Let's say X extends Y. Also Z extends X, let's say. So every arrow corresponds to extends. And usually you will only draw the arrows vertically. You wouldn't draw something like, let's say, X extends Y. No, it doesn't go this way. Got to be vertical, right? Just convention when you see any modeling diagram. So we say that Z directly extends X. X directly extends Y. So what I want to say here is you want to just know that we say Z indirectly extends X. Indirectly extends X. And this kind of indirect extension is actually very important. That helps us define ancestor and descendants accordingly, right? So I want to make this clarify, first of all. And then let's now find a reference point. Let's say we have A over here. So this is more like a general way to really represent inheritance hierarchy usually will be drawn as a tree, but don't worry about what a tree is really, because that's something you will learn more formally in 2101, the follow-up course. I think in this course, what you want to get some idea. What can be a tree? This is a tree, right? You got the top over here, you got also something at the bottom, right? And different layer, that's a tree, okay? That's all you need to know. And let's say we got some general tree over here. Let's say we'll focus on A over here, somewhere in the middle of the hierarchy, A. A could be, for example, Huawei, somewhere in the middle, right? And let's now try to define different terms over here. First of all, let's start with ancestor. So we got ancestor of A. By definition, if you look at the slides over here, will be class A itself. A class is its own ancestor. Mine sounds a bit weird, but that's the definition we're going to go by. Otherwise, the rule is not going to work for later, okay? Itself and also all the classes that either directly or indirectly extended by A. All right, how do we visualize this? All right, so if we start from A, what will be the ancestor? So I'm going to use green for this. Okay, ancestor. First of all, it would be A itself. Oh, let me make it a little bit thicker. It would be A itself. Also, the class A directly extends. So far, we got 2 ancestors already, but we're going to keep going. All the indirectly extended class by A, we should also include them. So you basically follow the arrow, go all the way up to the top of the hierarchy. This is also something called ancestor path. Okay, I'll write down one by one. So you go another arrow, this will be indirectly, and then the dot over here tells you can go as many as necessary until the top. So this will be the top of the hierarchy. Okay. So all these call the ancestor of A. Okay, A itself, and everything that's indirectly or directly extended by A. What is so important about ancestors of A? Okay. Think about inheritance here. If I only look at these 2 classes, only these 2, A and its parents, right? So in this way, you can see A inherits everything that's expected on its parents. This parent here inherits everything that's expected by its parents, and so on. What does that mean? That means A will inherit everything that's expected for all the classes along this path, all its ancestor. Right? That's really something you want to see. Okay, I'll write it down. So point number 1, A accumulates. the attributes and methods. And there's an implicit assumption here, which we said about visibility. Private attributes are not really inherited. So here what we're talking about is could be public attributes, could be package level, or could be protected from its parents, right? Not private, okay? That's something implicit. The attributes and methods from its ancestors. And the attributes and methods that are being inherited is what we call intuitively expectation. All right? And if you go back to that smartphone example we just did in the earlier page, that's doing exactly this. I just did some concrete example together with you first before generalize it. And let's now make some little derivation from this, but it's quite obvious. Given what I said in point number 1, in point number 2, I can say the following. The expectation of A, right here, should be larger than or equal to the expectation for all its ancestors individually. That's a very important insight. You got to keep that in mind. Okay? It will be larger than or equal to the expectation of any ancestor. Simply because we just keep accumulating attributes and methods. All right. Are we okay with point number 1 and 2? All right. Just give me one moment. So I just want to highlight this, and then before I take a question. Yes. Yes, please.
Point 2, we're still not talking about private.
Oh, yeah. And so at this point, we don't really, just for simplicity for our discussion here. So whenever we talk about expectation being inherited, we're assuming that it's either protected or maybe package level or even public, just no private. Yeah, that's our assumption. You'll see somewhere on the slides, especially around the end of the visibility part, we said for now on we assume all the attributes will be not private. Yeah, you'll see that. Yeah. Mm-hmm. It's a different angle for us to consider, but let's not distract our discussion. All right, so that's about ancestor. And then if you go back to the slides, you will see exactly that description there. You can take a look. So A will simply have wider range. So larger than equal to means wider. All right. And descendant classes, right? It's the other direction. But let's now just define them visually. Right? Descendant classes is going to be A itself again. So A is its ancestor and descendant at the same time. Just remember for our definition. Okay. So let's say descendants of A. Okay, so for that one there, I'm just going to use pink. Okay, so descendants of A itself, first of all. And then it's going to be all the classes directly extends A, also indirectly extends A. What about directly extends A? It will be just the level immediately below, right? So it's going to be right here. Here, and also here. But also indirectly, so it's going to include everything underneath it. Everything. Everything. So, for example, let's say, what will be the descendants of this particular class? It's going to be whatever that directly extends that, and also everything else. Everything else. Okay? Yeah, question?
For that next slide, way on the left where it says Z indirectly extends to X.
Sorry, say it again?
Like on the where it says Z indirectly extends to X, like the first example you did.
I say indirectly extends Y. I think it's a typo. Yeah, thank you. Thank you. I appreciate that, of course. Yeah, I definitely meant to write. I'm not sure what I said. Maybe I said maybe Y. Anyway, indirectly extends Y, for sure. Thank you. All right, so that's about descendants, and let's now write down the points. Okay. So the expectation of A right now, because you can think about as far as this sub-hierarchy is concerned, A is at the top. That means A is going to be inherited to all its descendants for its expectation, right? So expectation of A is inherited to all its descendants. So, number 2, consequently, you can think about the expectation of A. You see, expectation of A is larger than or equal to all its ancestors. At the same time, it's less than or equal to all its descendants, right? You can see that. Should be less than or equal to the expectation of any descendants. This page over here is so important to really see the relationship between the ancestor and also descendant classes and see their expectation. Because once we get to the rule of substitution for variable assignments, you will have to need this intuition and also observation as well. All right, any question? Yes, actually, just before you ask the question, what about this guy here? This guy here, and this guy here. Somehow they were not highlighted so far. So these are neither ancestor nor descendants, right? In which case, they might just make trouble when you actually talk about variable assignment. That's something we'll see later, but I want to highlight them, and then I'll answer your question. So this one here, so for example here, and also here, and also over here. We'll do one example. We'll do some exercise together. So, just about ancestor. So this one here, and also this one here. Neither ancestor nor descendants of A. They are not relevant somehow. Could be sibling, could be cousins, but they're just not relevant. The more relevant would be ancestor or descendants. Question?
My question is, so which ones are directly the descendants or ancestors of A?
How about this? Let's do the exercise together, and then you will see. Okay. But of course, the ancestor of A, first of all, you must include A itself. That's something you want to not forget. Okay, well, we'll see. Okay, let's do one example together. Okay. All right, so you keep this definition here handy before you get very familiar, but let's now do some example. Okay, let's say this one here. Let's start with this guy here, relatively to the bottom, right, to the hierarchy. How many ancestors do we have? How many, first of all? 4? Okay, good. This, and this, right? Agree? Okay, write it down quickly. So, yeah, just make sure. Okay, so for that one there, it's going to be itself. So Galaxy S25, and then Samsung, and then Android, and then smartphone. Okay, so these are the 4. And what about the ancestor for this one here, right? Can be iPhone itself, iOS, and smartphone, right? That one there is going to be iPhone 13 Pro, iOS, and then smartphone, ancestor, okay? And what about this one here? Does it have any ancestor? Just one, itself, right? Special case, but you gotta be careful. Just itself, smartphone. So right away, you can see that if you compare these two classes, this and this, you can see if you look at them, the only ancestor they share will be smartphone. So we say that's a common ancestor, right? So you can see here and here. If you try to go up, and go up, even these ancestors, they are not the same. So this is ancestor. At the same time, we said that that's the lowest a common ancestor for these two classes. Okay. So these two, the lowest common ancestor. All right. And for expectation, I'll leave that as exercise for you, right? That's something we did earlier. Okay, I'll leave that to you. So this part here we did right in the beginning of the class. So this part will be exercise for you. But I want to look at the descendants very quickly. Okay, for descendants. What about descendants for this one here? Does it have any descendants? Just one. Yeah, good. Somehow the opposite, right? You can see the highest class has only one ancestor. The lowest class has only one descendant. So kind of symmetric. Okay, so that one there, Galaxy, so only itself, Galaxy S25, that's great. And for the pink one, also you happen to be the lowest, right, in that particular branch. So only iPhone 13 Pro. Now, this one, how many? Well, you can count the whole tree basically, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, the whole tree. Because it's so-called the root of the hierarchy. So that's another term. So smartphone here, we said that's the root of the hierarchy. So here, I'll just say all classes in the hierarchy. Because it's the root. Right, just to get yourself familiar with the terminology, because we're going to use this to also define different terms, different rules. Oh, guys, any question? Okay, if no, I would suggest we take a short break by taking attendance, and then after the break, we're gonna dive deep into the substitution rule. Okay. All right, so I think for today, I will go very slowly because the rule of substitution is so fundamental. Everything else that we talk about, including typecasting, which we'll touch upon on Tuesday, also depends on this. So I'll go very slowly with this build up over here. I'm gonna walk you through the rule, and then I'll tell you what you should really study for inheritance before the over the weekend, before next class. Of course, whatever we talk about today will be covered in the written test. That's hopefully will give you some motivation to study this as soon as possible. Okay. Okay, so before this, let me just talk about some starter pages here just for you to do some quick exercise. Again, expectation, which is something we did. So the exercise you can try would be, you can see Jim over here was declared as static type students. Expectation really is about, when I say Jim dot, what can I expect to put over here and then still compile, right? Just for this one, what would that be? Basically, everything that's declared in the student class, right? It's going to be the name, courses, number of courses, and also the register and get tuition. So these are all the expectation for Jim, all right? So this one here, you can just see that it's going to be basically all the attributes and methods declared in students, which is the static type. All right. And you can do the same for smartphone. These two classes happen to be at the top of the hierarchy. But if I choose a class that's a little bit lower in the hierarchy, you will see that the expectation is going to become more and wider. For example, intuitively, this one here is going to include everything that's inherited from student plus something additional, right? So that's something I also want to just remind you. So now what about when I say Alan, which is declared statically as NRS over here. So this one here is going to be all the expectation of its parents, which will be students, plus everything that's newly declared in the non-resident student, right? Non-resident student is a static type. That should include the discount rates and also set discount rate. These are the two new things. The new attributes and methods in non-resident students. So overall, it's going to all the attributes methods plus these two, right? For this particular Alan. And you can do similar exercise for P2 and P1, phone number 1, phone number 2, right? That's also something you can try. Another thing you can try is this. If you put all the decoration and classes in Eclipse, if you type to say P2 dot, Eclipse can also show you the manual list about everything that's applicable. That really show you the expectation, even though Eclipse doesn't call that expectation, right? Similar. All right, so these two pages are very simple exercises, but I think that's important, so make sure you're feeling comfortable about expectation, especially when we talk about different locations in the hierarchy, okay? Hey, let's now talk about the rules of substitution, okay? And they will do examples, okay? This is some diagram that we saw earlier when we declare ancestor and descendants, right? We're gonna use something very similar, but we're just gonna add into the concept about expectation. Okay. Before that, let's think about what's the problem here. The rule of substitution is helping you solve about whether or not some variable assignment should compile, especially you're given some inheritance hierarchy. So here's the problem. We're given certain inheritance hierarchy, right? Including class A, somewhere in the middle. And we have some decoration over here. We got object A, we got object B. Object A has been declared as type A. Okay, let's now mark it down right away. So you can think about this A here correspond to the A right here, right? So think about what you write in the code and also what corresponds to the inheritance hierarchy visually. So the A here is the static type of OA. And if you like, I can also put it down over here. So this is a static type of OA. All right? And whatever that happens afterwards is not our concern, because for now, we only worry about compilation. Okay? So rules of substitution is only the rule for compilation. All right? So we got one object decoration, one variable decoration, and we got OB. And then I put the static type of OB to be question mark. That means there is a range of possibilities that we can put in OB. So rules of substitution is telling us the following. If I want to have a variable assignment right here, to say OA is assigned another OB. Now, what can be the possible static type of OB such that this variable assignment will still compile? That's the problem we are solving. Okay? What can the question mark be in order for this variable assignments to compile? Number one, right? That's literally what the problem is. And the question mark over here, of course, it is a static type for OB. And this one here, question mark, and the question mark right here. So the question mark is the static type of OB. Okay? Okay, so far so good. And let's now try to understand this one a little bit better. What do we really mean by variable assignments? This variable assignment here, there are different ways to interpret that. But the way that's going to be helpful for us will be, we're basically saying we are trying to substitute OA by OB. That's point number one. And then, after the substitution, we want, very naturally, once you have done the variable substitution, you will want to call some methods on the variable, right? Using a dot notation. We want something like OA dot something, right? So these two are the bullet points you want to also try to appreciate and try to understand over the weekend, right? You want to really digest, internalize it before we go further. Let's talk about these two bullet points very quickly. And then I still haven't got to the diagram just yet, but we want to understand what the problem is. So you can see that OA over here will be the expectation of OA's static type, which we know is A. So this part here is really defined by A. That means after this particular substitution, whatever we can do on OA is defined by the expectation on its static type, which is A. In order for this substitution to really work, we want to make sure this guy that's used for the substitution must be able to fulfill whatever that's expected from A. Cannot be less, but can be more. All right? This will be another important observation here. Okay, so for the start, I'm going to put it here. OA's expectation must be fulfilled. Fulfilled by OB's expectation. And we know that OA's expectation over here is A. And OB's expectation is the question mark, which we are going to see what it can be. All right, let's go a little bit further. In order to fulfill that, that means the expectation of the question mark should be larger than or equal to the expectation of A. This is very important, right? I want to make sure whatever I expect on OA, at least I will be able to supply that by OB's expectation. So that means OB's expectation, which is question mark, must be larger than or equal to, cannot be less than. If that's less than, that means I got something that's expected on A, but I cannot offer. Right? Think about what I just said there, right? That's actually very fundamental to this intuition here. And then when I say the expectation of question mark must be larger than or equal to expectation of A, what does that really translate into the diagram? That means a question mark must be a descending class, because we said that the lower you get into, the more expectation you have, right? Okay? You can see everything is somehow logical about expectation. This one tells you that, consequently, we know that question mark must be a descending class of A. This is the final rule you will see on the slides. However, to really make sure you don't really kind of memorize it, it might just get confused and memorize maybe the other way. You really want to see how things are being derived, what I just said. So maybe you watch a recording, maybe over the weekend, just for this part here, just make sure you kind of internalize into you. Okay, and just gonna summarize for you, right? This is something that I'm also gonna rely on you before Tuesday, okay? So that means this. Whenever I got variable 1 equals variable 2, all right? Let's say variable 1 has the static type, T1. And variable number 2 has the static type, T2. And we say that in order for this variable assignment to compile, it must be that T2 has wider expectation to fulfill for T1, right? So T2 must be a descending class of T1. Okay? i.e., the expectation of T2 should be larger than or equal to the expectation of T1. Yeah, today could be slightly dry. I will still do example, but I want to go over the rule very carefully with you so we can go a little bit faster on Tuesday on all the examples. Okay. Okay, that's something you want to keep in mind. And let's now go back to the inheritance hierarchy here. And now what can question mark be? Right? So now the question mark over here can be all the descending classes. Basically, because these are all descending classes. Okay? So now think about this question mark here can be A, can be this, can be this, can be any of the classes. If you put any of these classes over here, it's going to compile. However, if you put any classes outside this range over here, it's not going to compile. All right? So this will be the possible class for the question mark, which is the static type of OB that can make OA assign OB compile. All right? Anything else? For example, this part over here, be careful, okay, over here. The pink part over here, you cannot really say they are the descendants of A, right? Because descendants of A include A itself. But it is okay to put A here. So we will say the descendants of A's parents. Okay? These are the descendants of A's parents. Okay, I would say this, let me just say that's A here. Okay? And then other than that, you can see this one here. This one here, these are neither ancestor nor descendant, right? As we said earlier, okay? So this part here will be B. A and B are the classes where if you put those classes here, it's going to fail to compile, all right? Okay, for A and B, question mark over here. Any class from A or B will fail to compile. All right, any questions here? Pretty dry, but you know, still logical, right? So you really have to make sure, I think the most important lines, you want to make sure you understand. Here, and here, these two, okay? That's something I rely on you to do a little bit study over the weekend. Okay, let's now do some example. Okay. And in the slides I'll show to you, that's basically what I said already. So slide number 41 is just about accumulation, right? About expectation being accumulated. That's something we said. You can take a look. And also about expectation, right? It's really about what methods can be called on a particular reference variable, depending on what the static type is, right? That's also something we said. And substitution, right? So that's in general about the variable assignment, given our inheritance hierarchy. And then we got rules of substitution, right? We talk about being safe or unsafe. That's exactly the visualization I did. If it would be safe, if the right-hand side is a descendant class, you'll be unsafe if otherwise. Okay, so these are the three cases you can also look at. Okay. All right, let's now do some quick example to see how much we can go through. Give me one moment. Okay, let's do with this. All right, let's now do this. Okay, so let's now do the first one. Okay, good. So we got SP1, SP2, SP3, right? 1, 2, and 3. And they're declared using different static types. Static type number 1, smartphone, which is the one for SP1, right? And also we got for SP2 is iPhone 13 Pro, and also we got Samsung, which is the static type for SP3, right? We got 3 different variables. And now the question is, for SP1, what can we put on the right-hand side so that it's going to compile? What can I put? Yeah, go ahead, yes?
Put SP2 or SP3.
Yeah, I agree. Okay, let's see why. So here, this one here, it could be SP2 or SP3. Let's just see one of them for justification. SP1, if you look at that has the static type smartphone, which is right here. And then let's say SP2. That one there has the static type iPhone 13 Pro, which is right here. Static type is this. Static type is iPhone 13 Pro. And the question is whether or not this should compile. As long as the static type over here is a descending class of the static type over here, then we're good. Is it? It is. Because this one here is a descending class of that. All right? On the other hand, you can also try to figure out the possibility for SP2 and SP3. Oh, how about just do one together? SP3. What about the question mark? How many possibilities do we have? What can we put to make it compile? Anyone? Yeah, so over here you can see, well, we are only given SP1 and SP2, right? So let's not worry about the classes. So, okay, so here, okay, let me put it this way. If I got SP, let me just make it even more explicit for you guys. If I got SP3 equals SP3 equals, let's say SP1, SP2. Will they work? They won't, because let's now justify one of them. SP3 has the static type Samsung right here. SP1 has the static type smartphone, which is right here. In order for this to work, this right-hand side here must be a descendant class of this one here. Is it? No. Smartphone is not a descendant of Samsung, so it wouldn't work. Reason? You have to go back to what we talk about right here. Okay? That's something you want to think about over the weekend. All right? Okay, so that's just one example here, and then let's see anything else. Okay, how about we do a little bit more? Oh, actually, that might be something I just did, right? Okay, SP1, SP2, okay. I think, how about I leave these two pages empty for you guys to really do exercise, okay? So again, whenever you want to look at that, figure out what's the static type. And figure out what's the static type. This one here must be a descending class of this class over here. That's the rule. Okay, look at these two. Okay, I'll leave them empty for you to do exercise. All right, so after this, let's now do a little bit of dynamic type. Okay, just before that, let's now talk about some visualization. Okay, so when I declare some reference variable declaration, I declare that to be static type students. Okay, and then whenever I got a new keyword that tells me I want to create some objects at the runtime, so this will be dynamic type. Okay. So this will be dynamic type. And this will be static type. And the similar rule will actually apply, as you will see on the slides. When I say S is assigned to some new objects, I want to make sure whatever I substitute S by, like this one here, it must be able to fulfill what's expected on S. All right? I'll write it down as well. Here, the dynamic type resident students must be able to fulfill what's expected on S. So what's really expected on S? You have to look at its static type. So what's expected on S, we know that it's its static type, which is students. And now, can resident student fulfill students? Of course it can, because it's the descending class, right? And when you visualize it, you definitely want to make sure you put the dynamic type on the box. So this will be dynamic type. And this one here will be static type. Okay, static type. Typically, you don't really have to include a static type when the context is clear. But as we'll see next week when we do typecasting, static type is actually quite important to include, which we'll see. But I'm just saying for you to do tracing, you may just want to consider putting both, especially when the static and dynamic types are different. Okay. Okay, so that's good. Okay, let's now go over a little bit slides. Let's see where we are. Okay, and then we'll do a little bit tracing. We've got about 9 minutes, right? Okay, dynamic type. Dynamic type is basically the type of object that you're currently pointing to at a runtime, just the box. Okay, dynamic type may change whenever we try to do substitution. And there are two ways to reassign the dynamic type, right? That's something we're going to trace. I think that's also something we did earlier, but just to brush up a bit. That's about visualization. Okay, let's just do an example right away. Okay. So here you can see that we got Jim being the variable, right? Jim over here and Jim over here, just the same variable. Again, you can think about we got timing number 1, and then after that, timing number 2, and then it's right before, and then timing number 4, right? Let's just do this one carefully here, right? So what we have is timing number 1 is really about when we first declare Jim. And that one there is simply just pointing to null, right before, right? Just the variable, okay? So when we actually got for Jim, and then we got dynamic type. Timing number 1, dynamic type should just be null, all right? And after we assign this new object to Jim and store its address, this one is going to be the new dynamic type, resident students. So this will be after that. So timing number 2 is going to be resident students. And between 2 and 3, there's no reassignments, so remain the same. So timing number 3 remain to be RS, right? And finally, after this new variable assignment here, timing number 4, dynamic type should be this new one, non-resident students. Right? We did something very similar. However, there's something I want to also highlight. Both the RS and NRS. So these are valid dynamic types for Jim because they can fulfill the expectation on Jim. How do we define the expectation on Jim? Students, right here. So student will be the expectation on Jim, static type. And the static type is simply students. And we're saying that when you want to change the dynamic type, you better make sure that one there is a descendant class, so you can fulfill all the expectation. So one is resident students, which is descendants of that. This one here, non-resident student, is also a descendant class of that, right? Okay. That one's good. How about this one here? Can you do a line like that? Right? Imagine that you don't have Eclipse to help you. Now, can you decide, right? Of course, if you only try to look at the names of the classes and try to make some sense out of it, you might be able to guess. That's not the way to go. I might simply change the class names to be A, B, and C in the test, in which case you really have to draw the inheritance hierarchy and apply the rule, all right? So this one here is not going to compile, all right? Not going to compile, okay? Not compile. Because the dynamic type students, which is on the right-hand side, right? Dynamic type students is not a descendants class of Jeremy's static type, which is resident students. Okay, Jeremy's static type is right here. All right. If student is not a descendant class of resident student, it cannot fulfill its expectation. All right, so this one here, you guys can try exercise, right, for you. Think about when you got these two variable assignment, are they going to compile? All right, think about it. And this one here as well. So we got exercise 1, exercise 2. You can give it a try. And then let's see this one here. Okay. So I'll spend about 4 minutes to talk about polymorphism and dynamic binding. So these are the exercises you can try. One here, just about whether or not each one of them should compile, and each one of them. And the best way to do it is by looking at where they are in the inheritance hierarchy. The right-hand side must be a descendant class of the left-hand side, right? That's the way to judge, okay? And then this one here is just about when you get to gym.get tuition, gym.get tuition, which version should be called? We did that, right? Earlier today using Eclipse, right? You can give it a try too, all right? And let me just use this page here, and that that'll be it for today. Polymorphism and dynamic binding, okay? You will also see the definition on the slide as well. But these two things are really usually talked about together, right? That's really the essence about inheritance. Polymorphism simply means once you know about an reference variable static type, what can happen on the right-hand side? Once I know about student Jim, the static type, what can be on the right-hand side? Descending classes. There are multiple possibilities. If you got multiple possible shapes or multiple dynamic types, it's called polymorphism. All right. So once you know about a particular static type, multiple dynamic type, all the descending classes. So this one here is really about multiple descendant classes. Okay, just for your information, it's Latin, I believe. Poly simply means many. And morphism simply means shape. So given a particular static type, somewhere in the hierarchy, let's say here, and you can just use any of the descending classes, right? Any of them to be the dynamic type, right? That's polymorphism, about variable assignments. So whenever you talk about polymorphism, it can be achieved by variable assignments. And if you actually got polymorphism, for example, let's hear, it's unavoidable. You will have multiple versions of the methods. For example, let's say, given students as a static type, dynamic type might be resident students, or it might be non-resident students, right? Either one, depending on what's happening at the runtime. Depending on which one is the actual shape, we're going to call the corresponding method version for get tuition. right? So that's dynamic binding, okay? And object's dynamic type determines the version of the method being invoked, okay? So polymorphism over here is really about each descendants has its own version of the method. That's about polymorphism. And then for dynamic binding, it kind of tells you that to determine which version should be called, look at the dynamic type. Okay, so that's why these two are really looked at together. The gym example we did already. How about just this one very quickly? Okay, let's look at this one here. So we got P1 here, SP1, SP2. Okay, SP1 has smartphone and SP2 also has smartphone, right? And then dynamic type is iPhone 13 Pro, which is right here. And also we got Galaxy S21, which is right here. Okay, we got two different dynamic types. Okay. Now, if I say SP1.surfWeb, which version of surfweb am I going to call? Well, SP1 has the dynamic type iPhone 13 Pro, right? So that means we should really call the surfweb for iPhone 13 Pro. And if you look at iPhone 13 Pro, what's the surfweb version? It's not really overridden here, so go up here. Surfweb is declared and overridden in iOS version. Okay? So that one there. You know, how about this? I will talk about I will start from here on Tuesday. Make sure you go over everything we have said about the rules, and then I will talk about this one more time, and then as a recap. Okay? Thank you. I'll see you later.